Okay, so we'll continue. Okay, the question asks you a function f is discontinuous at a for 3 different situations. State the situation. Okay, earlier, just now we already discussed when is a function continuous. Yeah, somewhere here. For continuous function at point C, you see here, your limits from the left must be equals to the limits from the right. And if both of them are equal, we say that the limit exists. And for it to be a continuous function, this limit must be the same when you plug in the value of c into the function. Okay, so this is it for I think this is just your conceptual theory question. Okay, so I'll write A. Okay, so A how should I write it? But you know the concept is actually just the limit at A does not exist. Okay, maybe I should just write that. The limit at A does not exist, and we will discuss this later. I will talk a little bit more about this one, limit that doesn't exist, because you actually can have two situations that it doesn't exist. Then number 2 is that the limit exists, but you have a hole at that point. Okay, you have a hole at that point. Means your f of c is undefined. So it is a hole here, it is not continuous. So we say the limit exists, but okay, the limit at A exists. But f of A does not exist. Okay, or undefined. Then the third situation is both of them exist, but they are not the same. Okay, so this usually happens when it is like a piecewise like this, and in this case I think it is something to do with that. Means I purposely go and define equals to 2x and equals to x when x equals to 4. I purposely go and piecewise this one. I don't know why. Okay, so both limits at A and fa exists, but the limit at A is not the same as fa. Okay, so that's the 3 situations that function f is discontinuous at A. Okay, now I want to talk about limit that does not exist. Let me use a blank page. Okay, limits that fail to exist. Limit that fail to exist means what? The first condition is what we discussed earlier. When x approach c from the left is not the same as the limit when x approach c from the right. It can be because of the nature of the function. Like for example, fx equals to 1 over x. We know that when it approaches 0 from the right is positive infinity, from the left is negative infinity. Both of them are not the same. Hence, the limit does not exist, right? Then it can also be because of the piecewise defined function. Like a very typical example is like this. Okay, maybe a 1 and negative 1. Okay, this is what we call a unit step function. Because of the piecewise definition, so the function is suddenly discontinuous at this one. It can also be like this. Okay, it can also be like this. Like I said earlier, I purposely go and define that it is equals to some other value when x equals to c. And this is also discontinuous. This is for discontinuous. The limit exists. This one, the limits exist, yeah? This one, the limits exist, but it is discontinuous. But for this one, the limit does not exist because the left-hand limit and right-hand limit are not the same. Don't be confused, huh? Limits exist. A limit that fails to exist means left and right are not the same. Discontinuous it can be the three situations from earlier, not the same, fx undefined, or fx and limit not the same. Okay, now I want to talk about the second situation where the limit fails to exist, which is when you have an oscillating function. And a very typical example is fx equals to sine 1 over x and the limit when x approaches 0 of sine 1 over x. So if you really go and plot the graph, okay, you have something like this. Then when it is close to 0, it fluctuates. The value fluctuates between 1 and -1. Okay, 1 and -1. So if you zoom in, okay, you try to zoom in, you still don't know which one. You still don't know which one to take. So this is a problem. Then we said that the limit does not exist. Okay, alright. Then question number B, the function g is defined. So this is about continuous extension. Actually, we already talk about it when we did the last question, but never mind. Let's just go through the concept. Okay, continuous extension. Continuous extension is because sometimes the function is actually continuous when you draw it, but just it is maybe fx is undefined at that point. There's a hole in that function. So you need to go and define it or something like this. Okay, this is graph of y equals to 1 over x squared. The limit exists from both sides are the same, but it just happened to be that one point it is undefined. So you have to go and fill in the blank. I go fill in this one. Maybe you go fill in this. No, this one cannot. This one cannot. Okay, this one cannot, yeah. This one cannot. So continuous extension, you can only do that if the limit from the left and limit from the right are the same and they are approaching a value. Okay, let me write it here. The limit when x approach c from the left is equals to the limit of x approach c from the right, and it is equals to a constant value. It is not like something very crazy, infinity or negative infinity, or even fluctuate a lot, cannot. Okay, so this is continuous extension. So how you do the continuous extension is that you go and purposely define that at this point it is equals to that. Okay, for example, if it's c and then k, then I say fx equals to, okay, maybe the original graph is maybe gx when x is not c, and I purposely go and tell you that it is equals to k when x equals to c. And now you see what happened? Your limit from the left and from the right are the same, so the limit exists. And now your fx is defined, right? And then your limit and your f have the same value. Therefore, the graph is now continuous at point C. Okay, so this is continuous extension, but not every graph can do this continuous extension. Okay, as I said, it must fulfill this condition. Limit from the left, limit from the right equals to a same value, not infinity, not oscillation. Alright, so I think this is it, and we can come back to the question. Okay, so a function g is defined by this one. So determine the set of value of k such that g is discontinuous. Discontinuous, you see you have three conditions. The limit at a does not exist, means this one is limit. In this case, it is not oscillating. Obviously, it's not oscillating function. So from the left is not the same as limit from the right. This is what we can do. Okay, so this is the first thing that we can do later. Then the limit at a exists, but f of a does not exist. Also possible, right? Because you can see here, if your k is equals to 0, okay, if k is equals to 0, then your equal sign is here. Your equal sign is here. Means your result in the whole thing undefined. So it's also possible. then both limit at a and this one exist, but they are not the same. This one, is it possible to happen? It's not possible to happen, right? Because you already put your equal sign here. So it will, if it exists, then it should be the same. Okay? The limit exists means both sides must, we already said that both the limit exists means your limit from left and right must be the same. So number 3, you cannot happen for in this case. Okay, so let me clear this. And okay, so just now I already said that k cannot equal to 0. Just remember to write that in your final answer. Okay, let me erase. Okay, I need the space because I need to look at the function. So your x cannot equal to 0. Not your x, sorry. Your k cannot equal to 0. And now the limit from the left is not the same as your limit from the right. Fx is not the same as your limit from the right. Sorry, it's a gx. It's a gx. So how you gonna do that? This is from the left, this is from the right. Okay, so just go ahead and plug in the value. 5 minus 4 is not the same as 4 squared plus 2 times 4 minus 8 over 4k. So this is a 1. This and that can cancel. This is 16. 16 divided by 4 is 4. This is a 2. So k equals to 4 divided by 2, so it's 2. Okay? Not equals to 2. Oh, no, this is not a final answer. Because you need to determine the set of value. So your k, you know that it can't be 0. It should be k smaller than 0, or k in between 0 and 2, or k greater than 2. Okay, so this is the set of value of k, that the function is discontinuous. And you can also write this as what, you can write it in interval form. 0, union, 0, 2, union. Remember, it's a round bracket, because it is not inclusive of 0 and 2. Okay, 2. Okay. It's a union. You should write it in one line, but because I'm running out of space here. Okay, cool.